Have you ever wondered why some places experience long, freezing winters while others enjoy endless summer daylight? And why day and night are never equal throughout the year? The answer lies in a simple but powerful fact about our planet. The Earth is tilted. Today, we'll explore the inclination of the Earth's axis. Why does it exist? And how this tilt controls seasons, climate, daylight, and life on Earth. What is the Earth's axis? The Earth's axis is an imaginary line that passes through the North Pole, the center of the Earth, and the South Pole. The Earth rotates around this axis once every 24 hours, causing day and night. If the Earth's axis were perfectly vertical, day and night would be equal everywhere, every day. However, the axis is tilted, which causes the length of day and night to vary throughout the year at different places on Earth. Inclination of the Earth's axis. The angle of tilt is 23.5 degrees, 23.5 degrees. This tilt is measured from a line perpendicular to the plane of Earth's orbit. The plane of Earth's orbit around the Sun is called the ecliptic plane. So, the Earth is not upright. It's leaning slightly as it moves around the Sun. This tilt remains constant throughout the year, pointing in the same direction. And this single fact explains most major climatic phenomena on Earth. Formation of seasons. The most important effect of Earth's axial tilt is the change of seasons. How does it work? Effect of Earth's axial tilt on the Northern Hemisphere. The axial tilt of the Earth, 23.5 degrees, plays a crucial role in controlling the seasons, length of day and night, and temperature patterns in the Northern Hemisphere. When the Northern Hemisphere tilts toward the Sun, around 21st of June, summer solstice, the Sun's rays fall more directly on the Northern Hemisphere. Solar energy is concentrated over a smaller area. Days become longer and nights shorter. The duration of sunlight increases, temperatures rise. This results in summer in the Northern Hemisphere. At the same time, the Southern Hemisphere tilts away from the Sun. It experiences winter. When the Northern Hemisphere tilts away from the Sun, around 22nd December, winter solstice, the Sun's rays strike the surface at a slanting angle. Solar energy is spread over a larger area. Days are shorter and nights are longer. The Sun remains lower in the sky. Temperatures decrease. This leads to winter in the Northern Hemisphere. Simultaneously, the Southern Hemisphere experiences summer. During the equinoxes, 21st March and 23rd September, neither hemisphere tilts toward or away from the Sun. The Sun's rays fall directly on the equator. Day and night are equal everywhere on Earth. These periods mark the transition between seasons. March equinox, spring begins in the Northern Hemisphere. September equinox, autumn begins in the Northern Hemisphere. Key outcome. Because of the Earth's constant axial tilt, the Northern Hemisphere experiences regular seasonal changes. Seasons occur in a fixed annual cycle. Climatic patterns necessary for agriculture and life are maintained. Effect of Earth's axial tilt on the Southern Hemisphere. The change of seasons in the Southern Hemisphere occurs due to the same axial tilt of 23.5 degrees, but the effects are opposite to those experienced in the Northern Hemisphere. When the Southern Hemisphere tilts toward the Sun, the Sun's rays fall more directly on the Southern Hemisphere. Days become longer and nights shorter. The amount of solar heat received increases. Temperatures rise. This results in summer in the Southern Hemisphere. At the same time, the Northern Hemisphere tilts away from the Sun. Sun's rays become slanting. Days are shorter and temperatures fall. Winter occurs in the Northern Hemisphere. When the Southern Hemisphere tilts away from the Sun, Sun's rays strike the surface at a low angle. Solar energy is spread over a larger area. Days are shorter and nights are longer. Temperatures decrease. This leads to winter in the Southern Hemisphere. Simultaneously, the Northern Hemisphere experiences summer. Opposite seasons in both hemispheres. Because the Earth's axis remains tilted in the same direction as it revolves around the Sun, seasons in the Northern and Southern Hemispheres are always opposite. When it is summer in India, it is winter in Australia. When it is winter in Europe, it is summer in South Africa. Key point to remember. Without the inclination of the Earth's axis, both hemispheres would receive equal sunlight throughout the year. There would be no seasonal change. The concept of summer and winter would not exist. Variation in the length of day and night. Because the Earth's axis is tilted at 23.5 degrees, the circle of illumination, the line dividing day and night, does not pass through the poles for most of the year. As a result, day and night are unequal on most days. Equinoxes, March 21st and September 23rd. During the equinoxes, the Earth's axis is neither tilted toward nor away from the sun. The sun's rays fall vertically on the equator. The circle of illumination passes through both poles. Day and night are equal, about 12 hours each, all over the Earth. Seasonal significance. March 21st. Spring begins in the northern hemisphere. Autumn begins in the southern hemisphere. September 23rd. Autumn begins in the northern hemisphere. Spring begins in the southern hemisphere. Solstices. Solstices occur when the Earth's axis is most inclined toward or away from the sun, producing the maximum difference between day and night. June 21st. Summer solstice, northern hemisphere. On June 21st, the northern hemisphere is tilted toward the sun. The sun's rays fall vertically on the Tropic of Cancer, 23.5 degrees north. The circle of illumination shifts northward. The northern hemisphere receives more daylight than darkness. Effects. Longest day and shortest night in the northern hemisphere. Areas north of the Arctic Circle experience 24 hours of daylight, midnight sun. Marks the beginning of summer in the northern hemisphere. At the same time, the southern hemisphere experiences its shortest day and longest night. December 22nd, winter solstice, northern hemisphere. On December 22nd, the northern hemisphere is tilted away from the sun. The sun's rays fall vertically on the Tropic of Capricorn, 23.5 degrees south. The circle of illumination shifts southward. The northern hemisphere receives less daylight than darkness. Effects. Shortest day and longest night in the northern hemisphere. Areas north of the Arctic Circle experience 24 hours of darkness, polar night. Marks the beginning of winter in the northern hemisphere. Simultaneously, the southern hemisphere experiences its longest day. Effect at the equator and poles. At the equator, the circle of illumination divides the equator almost equally throughout the year. Day and night remain nearly equal, about 12 hours each, in all seasons. Seasonal variation is minimal. Toward the poles, the difference between day and night increases with latitude. Near the poles, days may last for several months, nights may last for several months. These extreme conditions occur due to the tilted axis combined with Earth's revolution. Key concept to remember. The greater the latitude, the greater the variation in the length of day and night. Polar day and polar night. Due to the 23.5 degree inclination of the Earth's axis, the circle of illumination shifts northward and southward as the Earth revolves around the sun. Midnight sun. Occurs within the Arctic and Antarctic circles. During summer in a hemisphere, that pole remains tilted toward the sun. The sun does not set for 24 hours or more. This results in continuous daylight, called the midnight sun. Polar night occurs during winter in the same regions. The pole tilts away from the sun. The sun does not rise for 24 hours or more. This causes continuous darkness, known as polar night. Example: North Pole experiences about 6 months of daylight, March to September, followed by 6 months of darkness, September to March. Without Earth's axial tilt, the sun would rise and set daily everywhere, and polar day and night would not occur. Heat zones of the Earth. The inclination of the Earth's axis causes unequal distribution of sunlight, leading to the formation of heat zones. Torrid zone. Lies between the Tropic of Cancer and the Tropic of Capricorn. Receives vertical sun rays, making it the hottest region. Temperate zones. Located between the tropics and polar circles, receives slanting rays, resulting in a moderate climate. Frigid zones. Found near the poles. The sun remains low or absent for months, causing extremely cold conditions. These heat zones influence climate, natural vegetation, agriculture, and human settlement. To sum up, the Earth's axis is inclined at 23.5 degrees. This inclination causes seasons, unequal day and night, polar day and night, heat zones, climate variation. A small tilt, but a huge impact on our planet.